Today on Capechi's Corner, we're going to look at solving equations involving absolute value. So we have some steps here that we're going to follow. The first one says to isolate the absolute value on one side. So what that means, if we look at letter A, here's my wall, and it means it just wants our absolute value by itself on one side of the equation, which it is. There's nothing outside there. Once we do that, we're ready for our next step. Separate into two problems. So we're going to separate them. The first problem, we're going to draw the absolute value bars. So we're going to get x minus 1 is equal to 3. And the second equation, we are going to drop the bars and negate the opposite side. So I'm going to have x minus y inside the same is the same, and that 3 becomes negative 3. And then I'm going to solve. Bring 1 to the other side. So I have x is equal to 4. And the same thing over here, I add 1 to the other side, and x is equal to negative 2. So that is my answer right there. All right, let's look at the next equation. So again, there's my wall. I do only have my absolute values. I don't have anything outside. We're going to get to those in a little bit. I'm going to split it. So I have 4t minus 8 is equal to 20. And then I have 4t minus 8 is equal to negative 20, right? We have to remember to make that a negative sign. Notice that when I split it, the absolute value bars go away. So once I do that, then again, I just solve it like a normal equation. Divide by 4, and t is equal to 7. We'll do the same thing on the other side. I'm going to add 8 to both sides, and I have 4t is equal to negative 12. Divide both sides by 4, and t is equal to negative 3. So they are my two answers. Okay, let's keep going. Let's look at letter C. So in this point, when I draw my wall, I do have the absolute value isolated, but I notice over here that I have a negative 4. Now remember, if I have something like this, absolute value of 3, that's positive 3. Absolute value of negative 3 is also positive 3. The absolute value is the number of units that value is from 0 on the number line, so it can't be negative. So there's really nothing for me to do here. I'm just going to say no solution, because there's no value that's going to substitute in for m that's going to give me an absolute value of negative 4. There's no such thing there. Sometimes you see the phrase either empty set or something like this, an empty set or a null set. So all of those. So nothing's going to work here. Okay, very important to be aware of that. All right, let's keep trying. The next equation we have, again, the absolute value is isolated, so I'm going to split it. Is equal to positive 21, and 8w plus 5 is equal to negative 21. I'll start with the first equation. I have 8w is equal to 16. Divide both sides by 8, and w is equal to 2. We'll keep going with our other equation. So I have 8w is equal to negative 26. Divide both sides by 8. Now that gives me negative 26 over 8. I can simplify that. Divide both sides by 2, and I get negative 13 over 4. So it's okay if you get a fraction. And your answer is allowed to be negative. It's just when you isolate that absolute value, it's not equal to a negative on the other side. Okay? All right, we're going to try some more advanced problems with a little bit more going on here. So here's my wall. And like we said, we have to isolate my absolute value. So now in this problem, I have my absolute value, but I also have that 4. So I can't split it until I get rid of that 4. So again, there's my wall. I'm going to subtract 4. And I have the absolute value of 2x plus 3 is equal to 5. Now at this point, my absolute value is by itself, so I can split it. So I have 2x plus 3 is equal to 5, and 2x plus 3 is equal to negative 5. Okay, I'll keep going and solve for x. Divide both sides by 2, and x is equal to 1. Do the same thing on the other side. 2x is equal to negative 8. So x is equal to negative 4. So they are our two values. Okay, we're going to keep going. Let's look at letter B. So again, there's my wall. Now again, I'm going to add 7 to both sides. I need to do that first. When I have that 3 right next to my absolute value, it means I'm multiplying. Kind of like when you have something like 3y, it's 3 times y. It's the same thing here. It's 3 times the absolute value. So the opposite operation is to divide. So we're going to divide both sides by 3. So the absolute value of x plus 2 is equal to 7. Now the absolute value is isolated, right? It's the only thing there. Now I can split it. So I have x plus 2 is equal to positive 7, and x plus 2 is equal to negative 7. So I have x is equal to 5, and x is equal to negative 9. Here are our final answers there. All right, let's keep going. So in letter C, here's my wall. And again, I have this negative 4 in front. So that's multiplied. So I need to divide. So I divide both sides by negative 4. So the absolute value of x minus 7 is equal to negative 4. Now, like we said in a previous example, once I have the absolute value isolated and it's the only thing on this side, if that's equal to a negative number, then there's no solution. There's no value that's going to work for x that's going to give us an absolute value of negative 4. Looking at our next problem, they look very similar, right? We're going to do our wall there. I'm going to divide both sides by negative 4. And I have the absolute value of x minus 7. This time is equal to positive 4, right? So just because we start with the negative doesn't mean that once the absolute value is isolated that it's going to be negative. So at this point, we can split it. We have x minus 7 is equal to positive 4. X minus 7 is equal to negative 4. So x is equal to 11, and x is equal to 3. Moving on. So again, here's my wall. This one looks a little different because I just have a variable inside, no other values, which is okay. So again, I'm trying to isolate that absolute value. So I'm going to add 3 to both sides. And I have 5 times the absolute value of m is equal to 10. Keep going like I have been. Absolute value of 5. I'm sorry, divide both sides by 5. Then I have the absolute value of m is equal to 2. Okay, so at this point we have our absolute value is isolated, so I'm just going to split it. So I have m is equal to positive 2 and m is equal to negative 2, and that's it. All set. All right, last one. Let's see how we do. Again, here's my wall. I'm going to subtract 7 from both sides, again, because that's positive 7, right? There's no symbol there, but we know that's positive. So I have 2 times that absolute value of y minus 3 is equal to 8. Divide both sides by 2. And I have the absolute value of y minus 3 is equal to 4. And so I have y minus 3 is equal to positive 4, and y minus 3 is equal to negative 4. So y is equal to 7, and y is equal to negative 1. And that's it. Okay, thanks so much for stopping by. You have a great day.